In this video, we are going to solve logarithmic equations. We'll discuss the two types of logarithmic equations, then give some examples. The first type looks like this. If you have a single logarithm on each side of the equation having the same base, then you can set the arguments equal to each other and solve. The arguments here are the algebraic expressions represented by m and n. The second type looks like this. If you have a single logarithm on one side of the equation, then you can express it as an exponential equation and solve. Let's learn how to solve logarithmic equations by going over some examples. Solve the logarithmic equation below. This is an equation of the first type, so we want to transform the left-hand side as a single logarithm. We can do that by using the reverse power rule to condense it. Here's the rule in case you forgot. So the equation becomes, distributing 3 to both terms in red, we can now drop the logs, then set the arguments equal to each other. We have 3x plus 6 equals 27. Then that becomes 3x minus 27 minus 6 equals 21. Dividing both sides by 3, we'll get x equals 7. Now, always check your solved values with the original equation to make sure that the solution is correct. Let's check x equals to 7. So we have the original equation, then we substitute 7 for x. That gives us this, which becomes that, and then finally that. Therefore, our solution is correct. Let's have another example. Solve the logarithmic equation below. Alright, let's solve this logarithmic equation. So again, the left-hand side, I can write that as a single logarithm. So I can write that as log base 3 of, let me use bracket, log base 3 of x, okay, x and that, so times x minus 2, okay. So I'm just using the product rule for logarithms that we also used in the previous example. That's going to be equal to log base 3 of x plus 10. So now at this point, I'm just going to equate my arguments. Arguments are the expressions inside a function. So that's just going to be x times x minus 2 equals x plus 10. And then I can now solve for x. So that's just x squared minus 2x equals x plus 10. Then I'm going to subtract. So I'm going to move all my terms from the right-hand side to the left-hand side. So that's going to be x squared minus 2x minus x minus 10 equals 0. Okay, then simplify. That gives us x squared minus 3x minus 10 equals 0. Now, all that's left to do is to factor our quadratic equation. Now, what are the factors of negative 10 that will give us a sum of negative 3? Well, that will be negative 5 and positive 2. If you multiply these two numbers, it will give you negative 10. If you add these two numbers, it will give you a negative 3. And so therefore, our factors will be x minus 5, x plus 2 equals 0. And that will give us x equals 5 and x equals negative 2. So now we have our solution. But we have to check which one of these, or if these two solutions are indeed solutions to the logarithmic equation that was given, because sometimes there's what we call an extraneous solution. It sort of pretends to be a solution, but it is not really a solution. So let's see. So let's test x equals 5. So what we're gonna do is we're gonna plug in x equals 5 to our logarithmic equation. So that's just going to be log base 3 of 5 plus log base 3 of 5 minus 2 equals log base 3 of 5 plus 10, okay, which will give us log base 3 of 5 plus log base 3 of 3, okay, equals log base 3 of 15. And we can go further. So we have log base 3 of, then again we can multiply our two numbers. So that's going to be 5 times 3, that gives us 15, and then on the right hand side gives us 15. So this is correct, okay? So x equals 5 is indeed a solution. Now how about -2? Okay, let's do -2. So I'm just gonna write that here. So that will be log base 3 of -2 plus log base 3 of -2 minus 2 equals log base 3 of -2 plus 10. And right off the bat, we can see that there's something wrong here, because we can't have a logarithm of a negative number. Okay, basically, the logarithm of 0 or a negative number is undefined. Okay, so we can't have a logarithm of a negative number, which means that this is obviously not a solution. And so therefore our only solution is x equals 5. Okay, so you have to test all your solutions to confirm if they are indeed solutions or an extraneous solution. Again, reiterating the following fact: the logarithm of 0 or a negative number is undefined. This means if the number inside the logarithm is 0 or negative when checking, the solution is extraneous. An extraneous solution is not a solution. Let's have another example. Solve the logarithmic equation below. Alright, let's solve this logarithmic equation. So again, our goal is to condense our left hand side and right hand side into a single logarithm. So how do we do that? Well, we just take note of our argument and the operation involved. So in this case, operation is a subtraction, and so if we condense this into a single logarithm, then what will happen is we've got a fraction, a division, and that's because of the minus operation, a subtraction operation. If that's plus, then we are to multiply our arguments, but in this case that's minus, so we have to divide. Okay, and then that is equal to, same thing here, we have a minus, we have a subtraction. Okay, so take note of our argument, so that's just going to be log base 5 of 2x minus 1 divided by 3x minus 12. Okay, so now we can equate our arguments, so we can have that as x plus 2 divided by x equals 2x minus 1 divided by 3x minus 12, and we can do cross multiplication, so we can have it as x plus 2 times 3x minus 12 equals x times 2x minus 1. Okay? Then we can do FOIL method here in the left-hand side. So we have 3x squared minus 12x plus 6x minus 24 equals 2x squared minus x. And then again, I'm going to move my terms in the right-hand side to the left-hand side. So we are going to have 3x squared minus 12x plus 6x minus 24. And then that becomes minus 2x squared plus x equals 0. Then we can combine like terms. So 3x squared minus 2x squared, that will give us x squared. So I'm just going to write that here, x squared. And then negative 12x plus 6x, that's going to give us negative 6x plus x, that's negative 5x. So that's going to be negative 5x. And then minus 24, just copy that, minus 24 equals 0. Okay, and so we now have our quadratic equation. Let me erase this one here. Okay, let me move this over here so we can work on it. Now again, we have to find factors of negative 24 whose sum is negative 5. So that could be negative 8 positive 3. Okay, negative 8 positive 3. If you multiply these two numbers, give you negative 24. If you add these two numbers, will give you negative 5. Okay, and so therefore our equation now becomes x minus 8 x plus 3 equals 0. Then apply zero product property. That will give us x minus 8 equals 0, x plus 3 equals 0, which will give us x equals 8 and x equals negative 3. Now again, we're not sure if these two solutions are really solutions, so let's test them. Let's plug them in to our equation. Okay. Alright, let's test x equals 8. So this is just going to be log base 5 of 8 plus 2, that's going to give us 10, minus log base 5 of x, which is 8, and then equals log base 5 of 2 times 8, 16 minus 1 is 15, minus log base 5 of, 3 times 8 is 24, minus 12 is 12. Okay, so then that will give us log of 5. So we have no problem here because these are all positive, so we can proceed. We can condense further, so that will give us 10 divided by 8 equals log base 5 of 15 divided by 12. We can simplify further. We can write that as log base 5 of 10 divided by 8 will give us 5 over 4. And then here, log base 5, we can simplify this, which will also give us 5 divided by 4. And so that is a correct statement. Therefore, 8 is indeed a solution. Now, let's try it with negative 3. So we plug in negative 3 for x. So that's going to be log base 5 of negative 3 plus 2 is negative 1. And right off the bat, again, we have a logarithm of negative 1. So you don't need to proceed further. The fact that you've got a logarithm of a negative number means that that is not a solution, because that is undefined. So that is not a solution. And so we only have x equals 8 as a solution. let's have another example. Solve the logarithmic equation below. This one is interesting because if you look at the right hand side, it is not expressed as a logarithm. So what we can do here is we can just convert this into an exponential equation. Okay, remember, if you have, say, log base b of say m is equal to n, then we can write that, we can express that as an exponential equation as m equals b to the power of n. Okay, and so that's what we're going to do here. So therefore we can write this as 8x minus 15, that's our m, equals 3 to the power of 4. Okay, and well, we know what 3 to the power of 4 is. 3 to the power of 4 is 81, and so therefore we can now write this as 8x minus 15 equals 81. Then adding 15 both sides will give us 8x, that's 0, equals 96. And then dividing both sides by 8 will give us x equals 12. Okay, so now all we need to do is check if this works. So let's plug in 12 for x, so that will give us log base 3 of, well, 8 times 12 is 96 minus 15 equals 4. So that's log base 3 of 96 minus 15 is 81 equals 4. And again, I'll convert this into exponential equation. This will give me 81 equals 3 to the power of 4, which will give us 81 equals 81. So that is a correct statement, and so therefore this is a solution. Let's have one last example. Solve the logarithmic equation below. Now this one is also kind of interesting because I can see a term with no logarithm. Okay, negative 1 is not expressed as a logarithm, so that makes it interesting. Now, well, there could be a few ways that we can solve this, but I think the easiest way to solve this is to take note of the fact that the logarithm of b base b is equal to 1. Okay, and so I can express 1 as a logarithm of any base. So I can express 1 as log of 2 base 2. I can express it as log of 3 base 3. And most importantly, in this case, I can express that as log of 5 base 5. Okay? And that's what I'm going to do here. So I'm going to write log of 10x base 5 minus, so instead of writing 1, I'm going to write log of 5 base 5. Now the reason why I'm doing that is because the base of my logarithms is 5. I want the bases to be equal. Okay, so then that's equal to log base 5 of 3x minus 1. Now I will condense my left hand side. I'm gonna write that as log base 5 of 10x divided by 5, because that is a subtraction. Okay, equals the log base 5 of 3x minus 1. Then I can pull out my arguments. 10x divided by 5 gives me 2x equals 3x minus 1. Okay, and then I'm going to subtract minus 2x both sides. So that's going to give me 0 equals 3x minus 2x is x, negative 1 is negative 1. And then adding 1 both sides, that will give me 1 equals, that cancels out, 1 equals x, or you could say x equals 1. Now let's see if this is a solution indeed. Let's plug that in to our original equation. So that's going to be log base 5 of 10 times 1, that's 10, minus 1 equals log of 3 times 1 is 3 minus 1 is 2, so log of 2 base 5. And then I'm going to rearrange my expressions here. So I'm going to write log of 10 base 5 minus log of 2 base 5 equals, and putting that on the right side, equals 1. Again, this is a subtraction, so I can condense that into log of 10 divided by 2 base 5 equals 1. This gives me log base 5 of 5 equals 1, which is a true statement. Okay, and so therefore x equals 1 is indeed a solution.